Good morning, all students. In previous lecture, we have obtained the expression of length element in curvilinear coordinate system. Also, we have obtained the expression of length element in orthogonal coordinate system, and that expression is dl square equal to g11 du1 square plus g22 du2 square plus g33 du3 square. Okay, this is the expression of length element in orthogonal coordinate system. Okay, so we write this equation in the form that is dl square equal to dl1 square plus dl2 square plus dl3 square. So here we have substituted dl1 square equal to g11 du1 square, dl2 square equal to g22 du2 square, and dl3 square equal to g33 du3 square. So further we write is dl1, that is therefore dl1 square equal to g11 du1 square. So like this, dl1 equal to root g11 du1. So we substitute the value of this metric coefficient which is in the root, that is equal to scale factor h1. Write this dl1 equal to h1 du1. Similarly, we write this dl2 and dl3, that is dl2 equal to h2 du2 and dl3 equal to h3 du3. So this value are required when we consider the next point, that is volume element in curvilinear coordinate system. So you remember this value, that is dl1 equal to h1 du1, dl2 equal to h2 du2, and dl3 equal to h3 du3. Okay, so next point we consider volume element in curvilinear coordinate. Okay, so here we consider parallel pipette of diagonal PQ and edges, that is dl1, dl2 and dl3. Right? So this parallel pipette has a diagonal PQ and we consider sides as dl1, dl2, dl3. Then we write the area element. So first area element we write is dA1 equal to, we consider side dl1 and dl2, right here dl1 dl2, right? Then next area element is write dA2 equal to, that is dl1 dl3, and third is write dA3 equal to dl2 dl3. Okay, so this is the first area element dA1, this is dA2 and this is dA3. So here we write the values of dl1 and dl2 as just we have calculated here. So write dl1 is h1 du1 and dl2 is h2 du2. h2 du2 equal to write h1 h2 du1 du2. Similarly, we write this area element dA2 equal to h1 h3 du1 du3, and for this we write h2 h3 du2 du3. Okay, so this is the area element, right? Then from this we write the volume, right here, dV equal to dl1, dl2 and dl3. So we substitute the values, so we get volume element dV equal to, that is h1, h2, h3, du1, du2, du3. So this is the volume element in curvilinear coordinate system. So this is the expression of volume element in curvilinear coordinate system. Now next we consider the volume element in spherical coordinate system. So right here, volume element in spherical coordinates. Okay, so we consider this diagram. Here the point P has spherical polar coordinate r theta phi. Right here P has coordinate r theta and phi. Okay, then we have to give increment to the position vector r by dr. Okay, that means we have to increase r by dr. Then straight line P2 is traced, giving or increasing r by dr. So straight line P2 is traced having length that is equal to dr. So right here P2 equal to dr, right? So we get this a straight line. Then we increase theta by d theta. Then area, surface area or surface PQRS is traced. Right here, when we increase theta by d theta, then r almost remains constant, not perfectly remain constant, but it almost remains constant. So there is a small change in the position vector. Right? So by increasing theta by d theta, then surface of area PQRS is traced, and this surface has area, that is right here PQRS surface has area equal to right here dr into r d theta. Because here theta is increased by d theta, so there is small change in r. It does not remain constant, but almost remains constant. So write this, that is r d theta. So we get the surface of area dr into r d theta. Right? Then we have to increase phi by d phi. So the volume is traced, and this volume has equal to, that is changing this by r sin theta d phi. So right here is r sin theta d phi. That means when an increment to phi is given by d phi, then volume is traced, and this volume is equal to, right here volume equal to dr, this is one side, then r d theta, this is second, and then r sin theta d phi. Okay, so this is this will get, that is volume element, or right here volume dV equal to dr, then r d theta and r sin theta d phi. This equation first. Okay, then we consider volume element in curvilinear coordinate system, and it has value dV equal to H1, H2, H3, du1, du2, du3. This is the equation second. So here we have to compare equation first and second. Then we write, that is the value of H1, there is 1, write H1 equal to 1. Okay. Then scale factor H2, as the value H2 equal to, this is R, right, and right this H3, that is equal to R sin theta. So this is H3 and this is R sin theta, right, H3 equal to R sin theta. Okay, so write this H1 equal to 1, H2 equal to R, and H3 equal to R sin theta. And let's write this du1 equal to, or first write this dr equal to du1, d theta equal to du2, and d phi equal to, that is du3. Okay, so in spherical coordinate system, the scale factor H1, H2, H3 has the values 1, R and R sin theta. Okay, so this is the volume element in spherical coordinate system. Then next we consider or obtain the volume element in cylindrical coordinate system. So we give the name, that is volume element in cylindrical coordinate system, right? So here is no need of diagram, so I do not draw the diagram, but from expression or from values we calculate the volume element in cylindrical coordinate, right? So we consider the point P having cylindrical coordinates rho, phi, z. So this point has cylindrical coordinate rho, phi and z, right? So we consider similar to the volume element in spherical coordinate. Same procedure we apply here. So first coordinate is rho, second is phi, and third is z, right? Then consider first point, and in first point we have to increase this first coordinate rho by d rho. Then we get the straight line PQ having length d rho. So here we take increase rho by d rho. Then straight line PQ is traced having length d rho. So first we get straight line of length d rho. Okay. Then next we have to increase the coordinate phi by d phi. So right here, increase of phi by d phi, right? Then we get area or surface of area d rho d phi. Okay, so increase of phi by d phi, we get surface of area d rho to one side and then rho d phi, because when we increase phi by d phi, then this rho almost remains constant. So we get the surface, and surface having area d rho into rho d phi. Okay, so this is the second. Then third, in third we have to increase z by dz. Then we get the volume, and that volume has total volume equal to d rho, rho d phi and dz. Okay, so increase of z by dz, the volume is formed. Volume is formed, and this volume is dV equal to d rho, rho d phi and dz. Okay, so in cylindrical coordinate, the volume element that we have calculated here is dV equal to d rho, rho d phi and dz. To name this equation first. Then again we compare this equation with the equation of volume element in curvilinear coordinate systems. Okay, so write this equation: dV equal to h1, h2, h3, du1, du2, du3. So comparing equation first and second, we have to write the values of scale factor and coordinate rho, then phi and z. Right? So right here h1 equal to 1, h2 equal to rho and h3 equal to 1. Right? Then you write this du, or first we write this, that is d rho equal to du1, then d phi equal to du2 and dz equal to du3. So here in cylindrical coordinate system, the volume element has the expression dV equal to d rho, rho d phi and dz. When we compare this equation with the volume element in curvilinear coordinate system, then we write the values of scale factor, that is h1 equal to 1, h2 equal to rho and h3 equal to 1. Similarly, d rho equal to du1, d phi equal to du2 and dz equal to du3. So here this is the expression of volume element in cylindrical coordinate system. So with this lecture I stop here. Have a nice day.